Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook, this question lost more marks than almost any other on last year's paper. A 3-mark median from a histogram, and students either wrote nothing or used the wrong numbers. Sound familiar? If you learn one interpolation trick today, you can turn that lost mark into a guaranteed 3 points.
First, the idea you must have in your head: in a histogram, the area of each bar represents frequency. Not the height alone, not the width alone, the area. That matters because some classes are wider than others, so we use frequency density, which is frequency divided by class width.
Quick concrete example. Imagine test scores grouped: 0 to 10, 5 students, 10 to 20, 12, 20 to 30, 18, 30 to 40, 10, 40 to 50, 5. Total students 50. If the class widths are all 10, frequency density is simply frequency divided by 10. So densities are 0.5, 1.2, 1.8, 1.0 and 0.5 respectively. Those are the bar heights on the histogram.
Why density? Because the histogram is drawn so that area equals frequency. If one bar is twice as wide as another, but the same height, its area, and so its frequency, is larger. Class width matters every time. Next, cumulative frequency. We build a cumulative frequency table by adding frequencies from the lowest class up. From our example, cumulative totals become 5, 17, 35, 45, 50. Plot those midpoints or upper boundaries against the cumulative totals and you get the cumulative frequency curve. Now, the median from grouped data, the logic. We don't know every individual score, only totals per class. Interpolation assumes the scores are spread evenly across the class. That lets us estimate the position of the median inside a class using a linear proportion. Apply it to our numbers. Total n equals 50, so median position is n over 2, which is 25. Look at cumulative totals: 5, 17, 35. The 25th value sits in the 2030 class. Good. Now, the interpolation formula every examiner wants to see is median equals L plus n over 2 minus CFB over F times W. That stands for lower class boundary, cumulative frequency before the class, frequency in the class, and class width. Plug in L equals 20, n by 2 equals 25, CFB equals 17, F equals 18, and W equals 10. So median equals 20 plus 25 minus 17 over 18 times 10 equals 20 plus 8 over 18 times 10, approximately equals 20 plus 4.44 equals 24.44. That's your median from grouped data. Tidy, and examiners accept that interpolation.
Do the quartiles the same way. Q1 uses n over 4, here 12.5, and Q3 uses 3n over 4, 37.5. Find which class contains those positions, then use the same L plus fraction times width formula. For this dataset, Q1 sits in 10 to 20, and works out to about 16.25. Q3 sits in 20 to 30 and is about 29.17.
Now, the most important part for getting marks: exam technique. Examiners award method marks when you show the right setup. For a median from group data, expect M1 for building the cumulative frequency or identifying the correct position, M1 for writing the interpolation setup, and A1 for a correct final value to reasonable accuracy.
So, what to write on the paper? Always write n and the target position. For median, write n equals 50, median position equals 25.
Show the cumulative frequency table with the class where the position falls. Then write the interpolation line, L plus bracket position minus CFB bracket over F times W, and substitute the numbers. Even if your arithmetic slips, showing the setup often gets you an M1 or 2. The examiner wants to see your method.
Common mistakes that lose marks. 1. Using frequency instead of frequency density when interpreting histograms. 2. Forgetting class width in the denominator. 3. Not showing the cumulative table or failing to state the position number. Don't make those slips. Write it down. Don't just think it.
Quick win, your 30-second interpolation routine. Step 1. Find n and compute the target position, n over 2, n over 4, or 3n over 4. Step 2. Write the cumulative totals and identify the class. Step 3. Note L, CFB, F, and W. Step 4. Use L plus position minus CFB over F times W and calculate. Do a one-sentence reasonableness check. Your answer must lie inside the class boundaries. If it doesn't, you've swapped a number somewhere.
Memorize this shorthand. L plus fraction times width, where fraction is position minus CF before over frequency in the class. Say it to yourself as you write the formula and you'll stop copying numbers wrongly. This is a grade 9 move. Quick, reliable, and marks are there for the taking.
Bonus. Guided practice at exam pace. Question. From the grouped data 0 to 10, 6, 10 to 20, 9, 20 to 30, 15, 30 to 40, 10, 40 to 50, 10. Find the median. Total n is 50 again. Median position 25. Cumulative totals 6, 15, 30. So median is in 20 to 30 with CFB equals 15, F equals 15, W equals 10 and L equals 20. Calculate. 20 plus 25 minus 15 divided by 15 times 10 equals 20 plus 10 divided by 15 times 10 equals 20 plus 6.67 equals 26.67. Write the steps and you get full method marks. Recap in one sentence. Use frequency density for histograms, build a clear cumulative table, and interpolate with L plus position minus CFB by F multiplied by W, and always show the position and the class to collect method marks. Let that sink in. That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Stay curious.